Unsupervised learning means I would like to create a model. Of course, the model is used to describe the data. So we still have data, and for each data, we still have a lot of features to describe those data. However, we don't have a target. We don't have a specific target when we deal with unsupervised learning problem. There has no target. There's no specific target to describe those data. So when we face such kind of things, what analysis we can do? First, since it is a data point right here, right, the red one, and there is another data point which is the green one. For unsupervised learning, there are several problems can be analyzed. First, distance. That means two data points, how close they are, how far away they are. What is the distance between data point 1 and data point 2? We can draw 2D surface, right? For example, we simply just use x1, x2, and x2. And here is your data point 1, and here is your data point 2. We can draw a lot of data points on this surface, right? And basically, the first question we would like to ask is, what is the distance between each data point? The most straightforward things. The distance is right here, right? So how do we calculate the distance? AB, right? B2 is CD. Distance between P1 and P2 equals 84. That is called Euclidean distance. So basically, when you try to analyze the data without any target, the first things you come up is, what is the distance between each data point? Of course, there are several distance functions, which I will show you later. However, Euclidean distance is the basic one. Here is a slide called distance function, scale, and similarity, okay? And then simply just go to the distance part, okay? Which is page 21. If we don't have any target, so there are just a lot of data points in a multi-dimensional space. The first thing we think about is the distance. So there are several distances. Euclidean distance, as we mentioned before, Manhattan distance, 曼哈顿距离。Manhattan distance is 曼哈顿距离就不用什么开平方或者什么平方之类的那个嘛，它就是把 x 跟 x 的差值，还有 y 就是另外一个 dimension y 跟 y 的差值，把它加起来就好了，这就是曼哈顿距离。那欧几里得距离就是我们用那个勾股弦定理嘛，然后就把它平方，然后再开根号这样子。There are several other concepts called similarity. The distance means if two data points, their distance value is larger, which means they are far away, right? However, similarity means if the value of similarity of two data points are smaller, which means they do not similar. 这是反过来嘛，相似度跟距离是一个相反概念嘛，对不对？你距离越大，表示你们两个离越远。可是相似度不是啊，相似度是你们相似度的值越高，你们就离越近啊，这个可以理解啊。Usually, 1 minus similarity equals to distance. Sometimes we say this. If the similarity, if you have a function called similarity function, or if you have a distance function, and this function will output the distance and output the similarity between two data points, and the value is between 0 to 1. Okay? If both these similarity functions and the distance function, they output the similarity value and the distance value are all between 0 and 1. And usually, we think this equation is correct. 就是通常我们会说啦，就是我们会设计距离公式嘛，或者我们会设计similarity， 就是相似度的公式嘛。那我们通常会把它定在0到1之间啊。 所以距离0的意思就是你两个根本就没有距离，是一样的。距离1的意思就是说你是我们这个空间体系里面两个天差地远的点，所以在距离是1啊。如果我们压缩到0跟1之间的话，那 similarity 也是反过来哈 ，similarity 就是如果我们两个 similarity 的值是1的话，就是我们两个根本就是一模一样的，在这个空间里面。我们的 similarity 是0的话，就是我们俩没有任何相似的成分存在，在这个空间里面我们俩就是相隔超远的点。那基本上，如果你是这样定义的，然后你的距离公式都会输出0跟1 ，similarity 会输出0跟1的话，那这个1减similarity 的值就是 distance， 或者1减 distance 的值就是 similarity， 这个就是也不是说常识啊，就是一般来说我们会这样子认为的。Of course, there are several other distance. We will discuss those distance or similarity very later, okay? In different algorithms. We can draw a similarity or draw a distance matrix. So that is data point. Data point 1, data point F, data point P, okay? So you can draw a two-dimension P and we have n points, right? P1, P2, Pn. If we have n data points, we can draw a similarity matrix or a distance matrix. The design of similarity function or distance function at the diagonal line, 就是在对角线的地方 okay? Because this cell means what is the distance between P1 and P1? And in our definition, there are this P1 and P1 are identical points. So the distance between these two identical points is 0. So in a diagonal line, there should be all zeros if you draw a distance matrix. And this matrix is symmetric, 就是它是对称的嘛。And this cell, that means what is the distance between P1 and P2? And right here is the same. What is the distance between P1 and P2? And usually, when we design distance function, the distance function should be symmetric as well. 就是我们设计那个距离公式的时候，我们也会把它设计成是对称的，就是 P1 到 P2 的距离应该是跟 P2 到 P1 距离要是一模一样的哈。因为有时候你会看到一些很莫名其妙的距离公式是 A 到 B 的距离跟 B 到 A 的距离是不一样的哈。那这样这就你在画这个 distance matrix 的时候就要特别小心哈。但是我们通常都会说这个是对称的嘛哈，所以它这个对角线是0，然后上半三角形跟下半三角形都是一个对称的distance matrix. Okay, that is one of the before we start to discuss the unsupervised learning, we have to say something about distance function. Okay, the very first unsupervised learning algorithm we like to share with you is clustering, which is UPGMA. UPGMA is so you may take a look at this UPGMA walkthrough. Okay, it is a slide. UPGMA, let's take a look at Google. We Google something like, okay, that's great. You can simply just Google, okay, family tree or Python, something like that. You can see that there are a lot of different trees. If I have a set of data points, okay, what is the first things that I would like to do if I would like to analyze those data points? If those data points has a huge amount of data points, for example, 1 million data points, from my opinion, usually we do not inspect those points one by one because you have 1 million data points. So the best things you can do at the first place is try to cluster them, which means if there are some points, they are similar, then we group those similar points into one cluster. And we would like to build the relationship between those clusters, just like the family tree, which I show right here. We have a lot of different animals, right, on the earth, but we cannot analyze all those animals. So the first thing is, if I have 1 million different animals, if I can find certain way to cluster similar animals into a cluster, and then if I can find a way to analyze the relationship between those clusters, and then I don't have to study all 1 million animals. If there are only 10 clusters that can represent all those 1 million animals, then the only thing I have to do is to study those 10 clusters, which is good enough for me at the first place, right? So the first thing is, how do I define the method to cluster similar animals into one cluster? So that is how this algorithm does. That is why we introduced this algorithm. UPGMA, it falls into cluster algorithm, which is unsupervised learning because it has no target. Take a look at this table. Okay, we have A, B, C, D, E, F, G. Okay, we have 7 data, A to G. And of course, it has several features, something like x1 to xm, which I don't know. But by using the distance function, which, for example, you use a Euclidean distance function, I can create a distance matrix like this one. So this is the distance matrix, the original distance. The diagonal should be O0 because the distance between AA, BB, CC, DD, EE, and GNG should be O0. And it should be symmetric. Distance between A and B is the same as the distance between B and A. But it's okay, we only use half of this matrix to run the UPGMA. Since we have the distance matrix of these 7 different data points, and would like to cluster the similar data points. So the first step is you find the smallest, the closest distance in this matrix, which shows right here is B and F, right? Because among this distance matrix, 1.00 is the smallest distance. That means B and F are quite close, right? So what is the UPGMA does? You simply, okay, use the green color, okay? You simply just write B and F right here. And because they are close enough, so they cluster at the first run. And you write 0.5, 0.5, and you connect B and F right here. So the height right here is 0.5. Okay, so that is the first step, because they are the closest pair. Okay. So the second step is right here. We would like to rewrite the distance matrix. So basically remove the B column and F column, and you remove the B rows and F row. Because these 2 points already combined it together. And you have to create a new row and a new column, which you just simply write BF. The next step is you have to fill out all this value. Because you create a new column, right, BF, all the value in this column is empty. Okay, at the first place it's empty. BF column and BF row, all those values are empty. Okay, so how do we fill this cell? Take a look at this one. The distance between A and BF. How do we find the value to fill in this cell? We think about the original cell. Originally, the distance between A and B is 19. Between A and F is 18. So, if we combine B and F to a small cluster, and the distance between A and this small cluster, BF, should be the average of AB and AF. So 19 and 18, so on the average, the distance 18, 50. 好，中文再讲一遍哦。我们把 B 跟 F 的两列全部都把它删掉，然后创造一个新的栏跟列叫 BF， 因为我们认为 BF 已经够小了，它们必须被 cluster 在一起，所以它这个新的点，这个新的点就叫 BF。那我们怎么把这 BF 的跟其他点的距离算出来呢？因为我们没有办法真的算嘛，对不对？所以我们就拿旧的表里面，我们现在算这个是 A 跟 BF 的距离嘛。那我们没有办法算 A 跟 BF 的距离，我们就回去偷看 A 跟 B 的距离，还有 A 跟 F 的距离，分别是18跟19。 那不如就随便做个平均吧，所以18跟19平均就18.5，所以那一格就随便填，就是平均填18.5。Okay, let's take a look at this the blue one, this one. I would like to know the distance between D and BF. So similarly, go to the original table to find the distance between B and D and F and D, which is 18 and 17. So on the average, the distance is 70-50. So we simply just average the distance in the original distance table. After we fill in all of the cells, then this run is done. Okay, we have a new cluster which is B and F. Their distance is 0.5. And we have a new matrix right here. Go to the next run. And this new matrix, which is the smallest one, is right here. A and D, the distance is 8. Okay, so we put A and D together and draw this height. Okay, that is 4, that is 4, so we add them, the height is 8. So next step is still the same. We try to remove A and D, which is right here, and create a new data point called AD. So the next, we create a new data point called AD, and we have a new column AD and new row AD. We have to fill in all those data distance by using the O distance matrix. So it's quite simple, right? Right here. For example, this blue one. I would like to know the distance between C and AD, and quite easily, okay? To find the distance of CA and CD, which is 27 and 26. And we write the average distance right here. The most important things might be this one, the red one. I would like to know the distance between the AD point and the BF point, which is the previous cluster, newly created cluster BF. Right? So how do we do this? We go to the original table and we calculate, okay? Since it is between AD and BF, so we find out AB, AF, BD, DF, and we simply just average it, okay? The average is right here, so we simply just put 18 in this cell, and so on and so forth. For example, find the smallest distance in the new distance matrix, which is BF and G, which is 12.5. And then we remove it and create a new column, a new row, which is BFG, and recalculate the distance by using the old distance matrix, the average distance, the distance between BFG and AD. At this moment, we combine BF and G. So right here, we put G right here, and we connect it. Okay, the distance is 16.5, right? So 16.5 is right here, and BF is right here, G is right, and so on, so forth, so on, so forth. And finally, we can combine this table all the way to the end. It's right here. We can gradually combine 2 points, no matter if it's the origin point A, B, C, D, F, G, or it is a cluster, intermediate cluster. We can combine them one by one, one by one, one by one. And here is the answer. BF will be combined firstly, and then AD and BFG, and then AD and BFG, and then C, and then E. So we can make a tree. So basically, UPGMA is a clustering algorithm, which shows you how those data points are related. So basically, you can apply this algorithm in all kinds of data like this. The data has no target, but it has several different features. And you can use these features and your predefined distance function to make a distance matrix. We will teach you how to apply UPGMA in Orange. Hierarchical clustering by using Orange, okay? And of course you need the data, okay? And most of the time, the data provided by Orange are suitable for classification problem or regression problems, so they do have target. But it's okay. We can still use the data, okay, to perform hierarchical clustering. So that's okay. We use the average data. Still, we have 4 different features, and we have 150 data points. So that's right here. So for hierarchical clustering, okay, as we mentioned before, it is unsupervised learning, right? So you have to see right here. Here, we have a tab that lists several different clustering. We'll mention some of them later. So very first things, as we mentioned before, the distance is the key to perform clustering. So take a look at this one. Okay, this delta, that is distance. So we drag a distance widget right here. Let's take a look. Just double click it, and we can see that the distance function. Okay, they have several different settings can be set here. The first one is distance between. Okay, usually because our data has different rows. For each row represents a data point, right? So we select rows right here. So the distance we'll have to compare is one row compared with another row, and so on and so forth. So that is rows. Next is the distance matrix. So there are several different distance functions. The first one is Euclidean distance, which I present to you. 有拉距离，不管是2维、3维、4维都是一样哈，就是在那个轴上相减，然后我们去算那个欧几平方平方和开根号的那个距离都是一样。OK。The second one, as I mentioned, Manhattan distance 曼哈顿距离就是在不同的维度上就是相减绝对值，然后就直接算和了，直接算和了哈。So there are several different distance right here. Okay, I will for example this one cosine distance. Okay, if I have 2 vectors in a space, how close they are, we can calculate the degree 就是角度 between these 2 vectors, and we can do projection 就是投影的长度这个我们算跟我们之前算那个 SVM 很类似哈。We can calculate the projection length by using cosine distance function, so that we can evaluate the distance between 2 vectors in the space. So that is cosine distance. We will talk about Jacob distance later, okay? There are several other distances right here. Usually, if we would like to evaluate numeric data, I think Euclidean distance is okay. So we connect our data to this distance widget. So this distance widget will create a distance matrix for us. So we don't have to calculate it by ourselves. We just simply do such kind of connection. And after that, we like to do hierarchical clustering, right? It's right here, like a tree. So drag it right here. We start it right here. Do you see that? The hierarchical clustering region, its input is distance. So we simply just connect the distance to the hierarchical clustering, and we're done. The algorithm used by this distance matrix and used by this hierarchical clustering widget is exactly the same as UPGMA. How do we observe the result? Simply just click. Okay, at left hand side, you can see that single, average, weighted, combined, there are several different parameters can be used in hierarchical clustering. If we simply just click average, it means UPGMA. When we say UPGMA, the A means average. At the right hand side, you can see that here is 150 data points, and it is the connection of those data points is decided by the distance matrix. And right here, since those data points are connected all the way to the root, right? Something right here. And here is a line right here, okay? You can drag it, okay? For example, you can drag it here, right here. You can set your own threshold to see how to partition this tree. If you can set it lower, for example, right here, so that we can have a cluster right here, cluster C2, cluster C3, cluster C5, and so on and so forth. You have to, for such kind of clustering algorithm, you have to decide where you make this cut. There are several different annotation right here. Because you don't have target, usually you can simply just use enumerate. Means data point number 9 will be combined with data point 14 and 39 right here. However, for this iris data set, we have target, right? So we can simply just select target, which is iris right here. In this cluster C2, they are all setosa in this small cluster. For C3, most of them are setosa as well, right? Setosa as well. Because the features in the 4-dimension space, they are closed. So we cluster them into one cluster, right? Of course, some clusters are not that clean. For example, C12, some of them are Virginica, some of them are versicolor right here, okay? But among them, among this cluster, only one data point belongs to versicolor. The rest of them are Virginica. That means one of the data point, which is a flower, right? Which is a flower, its feature is close to this cluster, so we cluster them based on the features, so on and so forth. Because such kind of family tree, we call it family tree. Such kind of family tree is very easy to understand and very easy to explain. So sometimes we use such kind of algorithm to analyze unsupervised data. You can simply just move the threshold to have different clusters, or you can manually select. Okay, I would like to have 3 or 4, 5, 6 or 10 clusters. That is hierarchical clustering. It is very nice to have such kind of algorithm. You can analyze them.